Working with key value observing is made a lot nicer and combined with the introduction of KVO Publisher. To use it, your object must arrive from NSObject, and the properties you want to observe must be both Objective-C and dynamic. Because of this, it is more likely you'll use this publisher when working with existing Objective-C classes, but you can leverage it for your own types if you want. Some classes lean on KVO rather than delegates to intercept events and to control behavior. And one example of that is AV Player. So let's take a look at an example that uses AV Player. We're going to extend this to add some behaviors to support some video playback features, and we're going to do that using KVO Publisher. So a quick overview of this application. It's got a player view controller up here. When we click load video, it's going to add a sample stream using an AV Player item, and it's going to add that to this. And then we can click play and pause. So if I do that, we click load video, and you can see a video kind of popped in, and I can click play, and we can see the video playing. And if I hit pause, it's going to pause the player, and if I hit play, it'll resume it. So one of the things we're going to need to do is when we hit load video, it creates a player item, and we want to observe that to know when that player item is ready to play. And doing that will allow you to read things about the player item, like the duration of the media. So we can look at player item.status, and this shows us the status, and that status can be something like failed, ready to play, or unknown. So it is common practice for you to use KVO to observe this to know when this player item is ready to play. So to do that, we can ask any NSObject to get a publisher for, and I can pass in a key path and pass status here. That's going to give me a publisher that will fire anytime the status changes. Then I can take that and do a sync, which will give us our status. And then I just want to set that on the status label. And we're going to be using self. So I will do weak self. So inside the block, we'll do this, status label.text equals status. And I added a string value extension down here at the bottom to give us some strings to use. I did the same for another type of status we're going to use it a little later. Okay, next we need to store this subscription, and this is what this warning is about. And typically I would say having a set of cancelables is a good idea, but for this, anytime you tap load video, we want to avoid adding multiple subscriptions to the same set that none of them ever get cleaned up. If I hit load video again, this is going to replace the player item, and we want to stop observing the old one and start observing the new one. So for this reason, it makes sense to have our own cancelable just for this one case. So this will be the player item status cancelable, and that'll be an any cancelable. It'll start off as nil. Then over here, we'll say player item status cancelable is equal to this. All right, let's give this a run. Now when we hit load video, it starts off with question marks, and then it tells us when it's ready to play. And we might even look inside of here and say, okay, when it's ready to play, let me go ahead and play it, but this is fine. The next thing I want to do is control whether or not the play or the pause buttons should be enabled or disabled. And you might be tempted to do that inside of here, but this is kind of the point of this functional reactive nature. We want to react to the state of the player, not the order of events that we tap these buttons. So for instance, if I intercepted this event for when the play tapped happens, what happens if I play programmatically? That's not going to set the state of the button. And if I decide to hit play in the player itself, that's also not going to synchronize the change because we're only handling it right here in this button handler. So instead, we want to observe the state of the player and have those buttons just always in sync. So to do that, let's add a set for our cancelables. And I'm doing it like this here because I want these to stick around because these are going to be set up in viewed load and they'll be done once. So here we're going to take the player and we're going to look at its player rate. Now the rate can be used to say set playback at 2x, but it can also be used to set playback rate to 0, which is the same thing as pausing. So what we can do is we can observe this. So I can use a publisher for the rate. And what I want to know is if the rate is 0, then I'm paused, and if it's non-zero, then I know that I'm playing. So what I want to do is map this to a Boolean that I'm going to call isPlaying, and this is going to basically say if $0 is greater than 0, then we're playing. So this is going to give us a publisher we can call isPlaying. So next I can take that isPlaying publisher and we can assign it to the isEnabled property on the pause button. Then we can take isPlaying and we can map this to not isPlaying, and then basically do the same thing here, but assign that to the play button. So basically they'll get the inverse. So there's many ways we could do this sort of thing. We could have added a sync directly in here and just do the logic there. It just depends on what style you kind of want to go with. Okay, so now we have the ability to react to the player's rate, and if it's greater than 0, then we should be playing, and the pause button should be enabled, and if we're not, the play button should be enabled. Let's go ahead and build and run this example. So now we immediately notice that the pause button is disabled, and this is great because the pause button shouldn't be interactable if the player is already paused. So when I click load video and we add our player item and it's ready to play, and I click this, now I'm playing, my rate is greater than 0, so the play button turns off and the pause button turns on. But what's great about this is now this is in sync with the actual player. So as I'm hitting play pause on some other means of manipulating the same state, our controls are reacting just like they should. Now the next thing I want to look at is the fact that you shouldn't be able to click play or pause if there's no player item loaded. And player has a player item, or a current item property that we can observe with KVO. So again, I can say publisher for current item. And here, let's do it in a different way. Here, we'll get the item in, and we can then use weak self so that we're not retaining self inside the block, and we can say that the play button dot is hidden is equal to that item being nil, and we can copy that exact thing and do that for the pause button as well. And then store this in our cancelables. So now we get the initial value for this KVO event, which is nil. So it sets all those buttons to nil or to hidden. And then when we load the video, now we can see play and pause are ready to go. And I can click play and it'll work. Now, one of the interesting things about AV Player is that it can transition between many different states depending on the state of the internet connection and if you're scrubbing, because I'm downloading an HTTP live stream, and so it's going to have to buffer some portion of that content before it can actually play. And sometimes you need to reflect that on the UI. So one thing we could do is take a look at the player time control status, and this will show whether or not we're playing, whether or not we're buffering, or whether or not we're paused. Now to do this, I want to sort of show this in a log, but it would be nice to know what the transitions are. So I'd like to get the old value and the new value. And this is a feature that you can do with KVO when we normally say add observer for key path. Say I add observer self, and for the key path, I pass in a key path, and then I can pass in these key value observing options. And those options allow me to pick the prior or the old value, the new value, and the initial value. Now, as we saw, we get the initial value automatically by this publisher. But even if we were to specify that we wanted the old value in our options, you can see here that the value that we get is always just the current value that that item is. So we're getting the current value of the property, and there's nothing in this combined publisher's output to change that to have a different type. So in this way, the KVO publisher is a little bit more limited than the old way of doing KVO, but we can get around that. Now, KVO Publisher does have the ability to take a publisher for a given type and pass in options. So if we pass in the time control status and we pass in options and I say prior, this, if you can look at the documentation here, it says whether separate notifications should be sent to the observer before and after each change instead of a single notification after the change. So what we're seeing here is that these notifications are firing, or these KVO events are firing after the item changes, and so we get the current value in the block. If I pass prior, for every change, we're going to get 2 events, one for the old value and one for the new value. Now this is kind of hard to work with because you have to know whether or not it's the old value or the new value. So instead of doing it like that, what we can use is scan with a careful use of a tuple as our initial value. So inside of scan here, I'm going to put this on multiple lines to make it a little bit easier to read. So we're going to be defining a tuple that has a prior value, and the type of this is going to be avplayer.timeControlStatus optional, and we're going to use .none as the value, or alternatively, nil is the value to think of it, but this is a way to give us that type automatically. So now we want the same exact type, but this one we want to call new. So we've got a tuple with prior with no value and new with no value. And we do it like this because we don't have a value right now to use. And so what we're going to do inside of our block, if you recall, scan takes in the accumulated value, which starts off with whatever we seed it with right here, and then some new value coming in. So when this publisher emits a new stream, it's going to start off with this value and then call it with that seeded tuple and then our new value here. So what I want to do inside this block is take the value that we had last time, which is tuple, and I want to return a new one that looks just like it. So we'll have prior and we'll have new. New is easy because we have the new value coming in. Prior can come from tuple's new value. So if you think about this, we're just kind of shifting each new value over to the left and storing that in prior. So that way, the next time through, whatever was here is going to shift over into this slot. And so we can kind of carry these over in pairs, which is kind of an interesting use of scan and makes this really useful. Now, one thing to note is that this new value is guaranteed never to be nil because when we call this block, time control status is not nil. So we can call map on this and return basically the exact same tuple, but force unwrap the latter part of it. So let's use $0.prior to carry that value, and then $0.new, but force unwrap. And this will sort of make this one non-optional because we guarantee that that's never going to happen. Now we can call sync, and now I get a tuple in, and we can store this in cancellables. And now we can check to see what's going on here. And I want to use a method that's declared on self. So we're going to use weak self here. And I'll just call self append log. And append log is just going to append some string value over into this black area here, which is a text area. And now we can say that we want to go from here. And then let's use a little emoji arrow. So this is the tuple's prior value, which is nullable, so let's just coalesce that to an empty string. Transition to the tuple's new value. And we want to use those string values that I mentioned earlier, which are defined at the bottom of the file. We've got time control status, so when it's paused, we'll return paused. When playing, we'll return playing. When we're waiting to play at a specified rate, I'm going to return buffering, and then for any unknown default, we'll just return a question mark. Okay, so let's give this a run. And notice that we transition from nothing to paused. And you can see that when I hit load video, we also get paused twice. So one thing we can do here is just say remove duplicates, because we're not interested in logging any behavior if it's the same as last time. So we click load video and you can see that it successfully skipped over that event. Now we click play and it goes from paused to buffering and from buffering to playing. And I find this kind of enlightening because you can kind of view the history of how these properties are interacting. If I decide to seek ahead in this file, you can see that it sort of pauses and then buffers, etc. And so this is a way we can sort of influence our UI, gain some understanding about how this is working. And we can decide to, show a buffering indicator or a loading indicator or something like that as it's seeking. Now, I'm on a very fast connection, and this is HTTP live streaming. But if this video was not optimized for streaming, or if you're on a slow, maybe cellular connection, then maybe that would be more appropriate, and you would see more of those. Now, lastly, before we wrap up, I think that this is a useful thing to reuse. And so one thing we can do is go down to the bottom here, and we could make an extension on publisher and have something called with prior value. Now with prior value would return an any publisher, and here is where we would return a tuple with prior as whatever our output type was, but optional, and a new value, which is whatever our output type is, but non-optional. So that's the new output type of our publisher, and then we can carry over whatever failure type our publisher is working with. So now it's just a matter of taking exactly what we wrote here and sort of making it a little bit more generic. So we go down here, paste this in. Here we can use output.none for both of these. I'll condense this back into one line. And then we map to unwrap it, and then we erase to any publisher. Let's give this a build. Delete that the dot there, because we don't need that, because we're just calling scan on self. And now we have a reusable function here that we can use. And I want to give credit to this to Rob Mayoff from Stack Overflow, and that's where I learned this trick. And I think this is very useful when you need to infer some behavior based on whatever previous value you had. So now we can go back up to the top where we're using that and replace this with prior value, and it makes a lot more sense now when we're just reading it like this. Okay, so that is a look at KVO Publisher. Now in this episode, I want to talk about future and deferred. And as an example, we're going to have this view controller that is going to show photos from the user's photo library. Now, what I want to point out about this particular example is that when we want to load photos, so we're going to have this button that says load photos tapped, and that is going to show up in the toolbar here at the bottom. And when I tap that, I want to load the photos. Now, typically when you do this, you'll look inside of PH Photo Library and look at the authorization status for whatever level of access you need, and that's going to give you a status. And then you'll have to switch on that status in order to handle things like, okay, it's authorized, I can go ahead and load photos, or it's denied, in which case I need to tell the user to, go to settings and approve. And then there's also not determined, which means we need a prompt for access. And to do that, we would use phphotolibrary.request authorization for our access level. And then we get this handler in. So this is a sort of asynchronous kind of completion callback based API. And this is going to give us our status. And then we need to essentially evaluate all these things again. So typically you'll have some sort of recursive kind of evaluate the status and then maybe call that same function again once you have a new status based on this request authorization call. So to me, that means it would be a lot easier if I had something like an authorization status publisher. So I'm going to create a private var authorization status publisher. This is going to be an any publisher for that authorization status. So this is PH authorization status and a failure type of never. Now, I'm going to make this a property that evaluates immediately. And I'm doing this because I want to illustrate this particular example. So that means when this class is created, it's going to evaluate this publisher right away. So then I want to essentially take this code and return it through that block. Now, to simplify things a little bit, I'm going to avoid doing all this stuff inside of here and instead just call this block directly. And our job is to turn this request authorization results into the value for this publisher. So how do we do that? Because I need to return something now, and this is going to take a block and give me the value later. So anytime you want to transition a completion callback based approach into a publisher, you're going to use future. So future is generic over the output and failure types, just like we've seen before. So we can specify those, but it can also infer those because I'm returning it from this block. And then I can call erase to any publisher. And how do we then deliver the value to the future? Well, futures take a promise. A promise is, you can think of these as two sides of the same coin. They both sort of promise a value in the future, but basically the future is kind of a read-only consumer of this value, and the promise is how you can tell that value tell that future it has a value or it failed. Another thing to note about futures is they're just a one call, one result, and then finish type of operation. So as soon as we get the results, we need to call our promise, and we need to pass in a Swift result. So it's going to be a Swift.result of our output type or our failure type, so kind of similar structure there. And we need to specify in that result whether we got a success, in which case we have a value, or it failed, in which case we pass in the error. In this case, we're working with a failure type of never, so we only have to worry about the success case, and I can pass in status like that. So cleaning this up a bit, now we can see I'm returning a future that executes this block. It requests authorization. When that comes back, we call the promise function with our result, and that will deliver the value through the publisher chain and then complete this publisher. So now if I run this, we can see that now I can use this just as if it were a value. I can say, okay, I only want to continue, so I'm going to use drop while and look at $0 is not equal to authorized. So maybe I just ignore all events until we see that it's not authorized. So once it's authorized, now I can use sync, and inside of this block, we want to then call fetch photos. And so I might use weak self here, and I don't care about the status, so I can use underscore and then say self.load photos, or fetch photos is what I called it. Now I need to store the subscription somewhere, and we have a cancelables set here, but this is a set of subscriptions that are essentially bound to the view controller instance. And because this is the result of a button tap, we don't want to use that, because if we tap the button multiple times, that'll result in multiple subscriptions being tracked and never cleaned up until this goes away, which is not really what we want. We just want kind of one load photos stream of events happening at a given time because you tap on the button. And if you tap on the button again, we should discard the old one and only listen to the new one. So anytime you have a situation like that, that is a good indication that we're going to want to say load photos cancelable as a separate cancelable that we can then set and overwrite. So we can say load photos cancelable equals this. So now we're retaining the subscription, but we're only retaining one of them. And if we call this function again, it will just overwrite the old subscription with the new one. Okay, so what happens if we run this code? Now, what you'll notice is it's asking for our authorization, but I haven't tapped the button yet. And the reason is that it's flowing through to this code immediately when this publisher is created. And this is the most important distinction to call out when using futures, is that futures will evaluate their block right away. They're different than other publishers. Other publishers will wait for the first subscription and then do the work and deliver the values, but futures do their work immediately. And in this case, that becomes problematic because I don't want to show this alert until they actually have a user action that is requesting photos, so it results in a much better user experience. So for that, it is often paired with the publisher deferred. Now, deferred is just a wrapper around any other publisher, and it takes that publisher, and it will defer the work until a subscription appears. So if we wrap this in a deferred, now it'll wait until we actually tap load photos to continue. And so to test this, we're going to have to go back here and delete this application and delete the data, and then run this example again. And the reason is this is the only way to reset that flag, so that when we tap load photos, now it is subscribing to this, which then invokes the future block. So now I can say allow access to all photos, and now it is fetching 6 photos, as we can see. So now we've got in this fetch photos, we need to actually do something with this. So to do this with PH asset, we call fetch assets with options. We get back a fetch result. And one thing I want to point out that we need to start paying attention to with this particular type of data structure is that this is not an array. In fact, it's designed around the fact that they never want you to potentially be storing all the results in an array. Your photo library might have 50,000 assets in it, and if I just said fetch them all, then we'd have a serious memory problem. So in order to get these, I can get object at a given index, or I can enumerate the objects using a block and sort of process them as a stream of objects rather than as an array. Now, this unfortunately isn't a publisher stream. And so what we're going to end up seeing is we get the asset, the index, and then a variable we can use to stop the iteration if we need to. And now we can process this. But I would like to use this kind of like a publisher because I want to then request images for each one of those assets. And those images are also asynchronous. So what we're going to do here is set up an asset subject, which will be a pass-through subject. And that'll be of ph asset and failure type of never. And then what I would like to do is tell that asset subject to send all of these assets through it. So we've kind of using a subject as a bridge to bridge this API through this subject. So before we send these values through, we're going to need to subscribe to this subject. So I'm going to say asset subject. And at this point, we want to kind of map the asset, right? We're trying to go from ph asset into a UI image. Now that itself is asynchronous, and so that's also going to be a publisher. I've created a function down here called image publisher for asset, which is going to return an image publisher, but is otherwise unimplemented. So let's start here and work inside out because I think that'll be a little easier to understand. So for an asset, we need to use ph image manager .default .request image for target size, etc. So we'll pass in the asset, the target size that we're trying to grab, the content mode, and then these request options. Now these request options are basically saying, give me the fastest one you can, but resize it to the right size. And if you need to download it from iCloud, go ahead. So that means this is definitely going to be an asynchronous operation. And then it's going to call this result handler with an optional image and then some info dictionary. So we'll have an image and an info dictionary. Now, image might be nil, in which case info dictionary might contain an error. But just for the sake of an easier example, we're going to be working with a failure type of never. So I'm just going to pass along the nil. So in this case, I need to somehow turn this API into one that it returns a publisher. And we already learned how to do that. We can use future here. So I will return future, take that promise in, and then we will move that down to the bottom and indent this code. So now I just need to call promise with success and our image. Now in this case, this is only done when we request it. So it's okay that we are, because we're going to subscribe to this right away anyway. So it's okay that we are using future in this way. But in other cases, we might want to wrap this also in deferred. Just depends on your use case. So it's complaining because we need to erase to any publisher to match this return type. And now we have an image publisher that'll take an asset and return us a publisher for an image. So if you think about these kind of like Lego building blocks, these pieces now can snap in together. And now I just want to use that here. Now I mentioned that what we have here now is an image publisher for a given asset. And whenever you're returning a publisher from a map, instead of using map, we want to use flat map. Now here I want to say that we're going to be passing $0. So everything that passes through this subject will be passed over here. We'll return a new image publisher for that. And then we will uncomment this target size so we can use it. And then the content mode here will be aspect fill to fill that target size. So at this point now, if we were to take a look at this publisher is now returning optional images. It's kind of hard to see here, but you can see the output type is now optional image. So I don't really care about optional images here. And so we can use compact map to filter those out. So basically it'll just eliminate all nils out of the resulting publisher. So now our publisher type has a publisher output of UI image. And again, it's really kind of hard to see when you're dealing with all these different types here, but just kind of, squint and think, what is my output type at this stage? Because I use compact map, my output type is now UI image. So now I want to take that and I want to turn it into a snapshot for my collection view. The snapshot is going to require these to be in an array. So I want to collect all of the results back into an array. So that means that it's going to start it's going to wait right here until it gets a completion event from the upstream publisher. And because asset subject currently never completes, it's going to wait here forever. So we need to make sure that when we're done enumerating, we go down here and say asset subject.send completion and tell it it's finished. So this whole enumeration is going to send all the values, and we're done enumerating. It's going to send this completion. Now, it is also important to note that this enumeration is done synchronously. So you can read that up in the docs. If this was asynchronous, then we would actually fire off this asynchronous block and then complete prematurely. But as we'll see, it will send all these assets first and then finish. Okay, so now after collect, we can then sync, and now we've got an array of images, and now I can apply that to a snapshot. So I'm just going to paste in some code here that is going to create a diffable data source snapshot, and it's going to append all of those images into the section and apply it onto our view controller with an animation. Okay, so I'm going to delete this right here, and now we just need to store this subscription. This whole pipeline needs to be stored somewhere. And again, because this could be a result in multiple button taps, we want to do kind of the same thing here, is create a separate cancelable, and this one I'll call load images cancelable, which is an any cancelable, and then we'll assign that here. Load images cancelable equals asset subject, and then all of this. Now, I do want to point out that this does work. If I run this, we should see our images, click load photos, and now we see 6 images in the list. Now, let's examine for a second what this flat map is doing. It's taking every value that comes out of the subject and creating a new publisher, which is then going to fetch those images. So if we had 50,000 photos in this result, that would result in 50,000 image requests almost at the same time. And I don't want to overwhelm the system to do that. So this is kind of why Max Publishers exists. It allows us to say that, hey, I only want to do 2 at a time. Now, this seems like an appropriate response. And if I run it, we'll see we get a little bit of a problem. Now I only get 2 photos. Even though we fetched 6, I only see 2. To understand why, we're going to have to sort of see what's happening here. So let's add a few print statements. I'm going to say sending asset and pass in the local identifier for that asset. And then print done with assets. Okay, so this is going to show us when we're sending those through the subject. Then I want to talk about this image publisher. And I want to have a print statement on the end of this. And this is going to be the image publisher, and I'm also going to paste in $0.local identifier so we can distinguish different image requests based on their identifier. And then finally here we can print, and this is our flat map subscription. So let's run this again and see if we can identify what's going on here. Okay, so over here we fetched 6 photos, and we sent our first asset through this list. Then you can see the image request for that asset received a subscription and requested its values or requested its demand. And then the second asset was sent through the subject. And again, we create a publisher for that image request. And now those image requests are now in flight. But the subject is still sending assets. And because the max publishers, we've reached our limit here. And so we're ignoring the events coming down from the subject. Then it says we're done with the assets. And then finally, these images start coming in. And now we receive finished from the upstream publisher because the upstream subject has finished. And we've received all of the pending publishers that came out of our flat map step here. Now, the flat map says I'm done. So what we really needed to do is kind of wait and not deliver these values while they are waiting for some of these publishers. Now, to do this properly requires us to write our own publisher so that we can manage this ourselves. And this is called back pressure management. It's an important topic, and we do have the flexibility to solve this problem the right way. But we're going to cover this in a later video when we talk about custom publishers. For now, I just kind of want to simulate this particular approach. So one thing I can do is call collect on this upfront. This is going to turn individual assets coming down the stream, wait for completion, and return an array. Now, I did mention that this is a bad thing to do if we have 50,000 objects in there, but for the sake of this example, it will suffice. So then I want to turn that back into a publisher of individual events, but one that does honor back pressure. So I can take that array and turn it into a sequence publisher. Sequence publisher is going to honor this back pressure for us. So this is going to allow us to see what's going on. And let's add another print here. We'll call this the asset array so that we can see what's happening here. Okay, so let's examine this output. Our asset array received its subscription from Flatmap, and it requested 2 items from this publisher. So even though we're sending all these assets through, we only requested 2 from the upstream publisher. Asset array receives its value, and you can see that the image array for that value is requested. Then asset array received its second value. Then once that image request comes through, as you can see, this image request finished. And as soon as this finishes, it frees up a slot in this max demand here. So once one finishes, now there's room for another one. So it requests another one from the upstream publisher. So now it says, okay, give me one more. And it gives it one more. Then as soon as one of these finishes, if we look for an image request finish, now we get another one. So as you can see, it's only doing 2 at a time. And as soon as the slot is freed up, it requests another one from the upstream publisher until they're all done. And the end result here on the right is that I still get all of my values. Now, I do want to point out that this is not a good solution to this problem. I just want to illustrate what back pressure management can do. It can turn in kind of a fire hose type of API and turn it into one that you can handle at your pace. So we're going to talk much more about back pressure management when we get to custom publishers. For now, I just wanted to show this as an example of what we can do with simulating this approach by using an existing publisher and also using future and deferred to wrap existing APIs that take callback blocks and exposing that as a publisher. All right, let's look at another demo, and this time we're going to use a new publisher called Notification Center Publisher. Now, notifications are used kind of as a broadcast event to broadcast messages kind of decoupled from where they happen and allow any interested party to react to them. And they're central to how UIKit works. And as an example, let's say we have this application here. It's kind of like a chat application, and we've got a message bar at the bottom and a send button. And when I tap on this, you can notice that the keyboard comes up and covers the interface, so it's not the greatest. And we need to move this up to show a little higher when the keyboard is present, and then when we hit the send button to have it go down again. And to do that, we can use notifications. And so if we look at our notifications center, .default, there is these add observer for different types of notifications. If we use this type, then we have to pass in an Objective-C selector. So if you're using your own Swift types, you're probably not going to be using this one. And there's also the add observer for name, which allows it to use a block to handle the notification. Well, now Combine supports a third option, which is to get a publisher for a given notification. What we're going to use this for is the keyboard will show notification, and that comes from UI application, keyboard did show or did hide, or will show and will hide. So I want to talk about these for a second. So this will show notification, and that'll give me a publisher for that. And if we take a look at the output of this, the output type is going to be notification, and the failure type is going to be never. So what we can do here is call sync, and now we get the notification. And then let's just print out the notification so we can see what's happening here. And I need to store this in our cancelables. So I open up the keyboard, and you can see that this gives us a lot of useful information in its user info hash. Now, not all notifications are going to be like that, and so often you'll just ignore the notification parameter, but in this case, there's a lot of useful information that we can use here. And so the one I want to start off with is this keyboard bounds, and there's also the frame end, which is basically what we want. This is going to show us the exact height of this keyboard. So what we can do here is maybe map this to get, we're going to get the notification in. And what I want to return here is a CG float that we can use to alter a constraint that we're using to kind of pin this to the bottom. So I'm going to take the notification user info, and that's optional. So we're going to get a key, which it comes from UI responder, but we can just use self like this. And this will give us the keyboard user info key, and this gives us all the different user info keys that we can use. So the one I'm looking for is frame end. So this is basically what the frame is going to be at the end of this animation. So that'll give us a frame. And because this is it's nested in this dictionary, it actually comes through as an NS value. So we're going to do this. That gives us an NS value. And then on the end of that, we can ask for the CG rect value. So it's a little bit wordy, but this will give us a CG rect value. Then I can return bounds.height, or maybe 0 if it's nil. So now, instead of getting a notification, now I'm going to be getting kind of an offset that I want to use. And I can set our safe area constraints constant to be the negative offset. So it'll push it up. And here we're going to use unowned self, because I know that I'm binding this whole pipeline to self because it's stored in cancellables, and none of this is going to happen if the view is deallocated. So now if we run this and I tap on this, you can see that it shows up at the top. And if I click this button, it dismisses the keyboard but doesn't go back down. So now we have to do kind of a similar thing for the will hide notification. And so I'm just going to copy this code here, and we're going to add another one for the keyboard will hide notification. Now in this case, I really just want to return 0 to kind of turn this into a 0 offset. And then we'll be kind of setting the constant in exactly the same way. And I'm leaving it negative here just to show that these two sync blocks are exactly the same, even though -0 is not going to have any effect. So now if I tap on this and then I hit the send button, it goes down. But it would be nice if it wasn't so snappy, if it sort of matched the keyboard animation itself. And as we saw in the output, there's other parameters that we can grab, not just the frame end, but we also got the animation duration and the animation curve, so we can add our own animation and time it exactly to match this keyboard. And because I want to do this in two times, I want to add an extension on Publisher where the output type is notification and the failure type is never. And we can maybe call this extract keyboard info out of that. That's going to return a new publisher that has some type here, and I don't really know what type I want, so let's just make one up. We'll just make a struct here called keyboard info, and this is going to take all those parameters I want, like the bounds of the keyboard, and then maybe the animation duration, which will be a time interval, and then we also want the animation curve, which is a UI view.animation curve. So now I want to create a publisher of that keyboard info with a failure type of never. So we're basically going to do a similar thing here. We'll start with map and get the notification in. And then we need to get the bounds, which we already got up here. So it's going to be kind of this same code here. We'll paste that in. Now, the only thing different about this one is we can no longer use self here. So this is actually attached to UI responder, so we can use that instead. So at this point, now that part should work. Now I want to do basically the same thing to get the duration. That's going to be from the notification, we'll get the user info dictionary, and then we'll use UI responder.keyboard duration, animation duration user info key. That is going to be an optional NS number. And then we can get the float value or maybe the double value out of that. So we can easily convert that to a duration. Now I want all these to have a value, so if they don't, I'm just going to use CGRect 0 here, and here I'm going to use a 0 for the animation duration. And then for the curve, it's a similar process. We'll grab notification.userinfo question mark UI responder.keyboard curve user info key. That's going to also be an NS number that contains the integer value of the animation curve value. So we can now get int value out of that. Now, instead of doing that int value, we can call flat map. Now this is, again, remember this is Swift's flat map, or the standard library flat map, which is going to take this optional value and optionally apply this block. So here I can return the UIView.animation curve and pass in the raw value here. So I actually do need to convert that to int value first and then call flat map. So if any of that is nil, then we can use our own curve of maybe ease in out. Okay, so now I can return a keyboard info with bounds, duration, and curve. Okay, and then we need to call erase to any publisher. Let's see, and I misspelled this. Ease in out. What else is wrong? This may need to be wrapped in parentheses here. There we go. So it's a little bit complicated, and this is why I want to kind of tuck it away in this this little operator we've made to make this code kind of disappear. Now I've written it once and I don't really have to look at it again, and we're going to use it 2 times up here. Okay, so now we can go over here and call extract keyboard info, and now I have a much easier type to work with. So I can map to maybe $0.bounds.height, and we can move the negative into here so it doesn't have to be there. And now we can kind of see that these two are going to be very similar. We're going to have this one, which returns negative bounds to height, and this one returns 0. So if I clean this up a little bit, maybe we can start seeing some similarities here on how we can combine these together. So I want to take the will show publisher and just get a reference to the publisher itself. And I'll also add in the extract keyboard info. So we can kind of treat that as one thing. Then we're going to have the will hide, which is going to be the same thing here. We'll take this guy and we'll also add the extract keyboard info. So we've got both of these things. So now what we can do, I'm just going to delete this code here so we can kind of focus on what I want to do. We're going to take the will show and I want to map this to negative $0.bounds.height. So I'm mapping it to the offset that I want to use. Then I want to merge this publisher with the other one, which is going to be the will hide publisher. And this one is going to be mapping its value to just 0, which means I need to ignore the value coming in. Okay, so now I can take that and have a sync and just get the offset. And now we can update our safe area. So let's use unknown self and then safe area constraint.constant equals offset and store in cancellables. So we're still not dealing with the animation parameters, but I wanted to talk how we could merge these two things together, which makes this code kind of a lot easier to work with because we've kind of translated each one of these publishers into the offset that we want to work with. So let's just make sure that this still works, and it does. So it's kind of nice that we have one stream now rather than multiples. So I do want to carry over those animation parameters. So let's, instead of returning just one value, let's return a tuple that has the offset, the duration, which will come from that parameters there, and then the curve, which will also come from $0.curve. So now we're returning a tuple. Now I'm going to copy this code and we're going to do the same thing here. So instead of mapping to just a 0, we can map to an offset that includes 0 as the offset. So now in here we've got our params, which are going to include this duration and curve. So what I want to do now is use UIView property animator. So we're going to create a new animator, UIView property animator, and we're going to use a one that takes the duration and the curve. So here we can use params.duration and params.curve. And for the animations, we can now add in our safe area constraint update. And then we also need to tell the view to layout if needed, which will actually trigger the animation based on this auto layout model change. This needs to be params.offset. Let's give this a build. And now we need to tell our animator to start its animation. And let's run it. And now we can see that our animation is synchronized with the keyboard because we're using the exact parameters that come from this. Now the will hide and the will show currently have the same exact duration and curve, so we could have hard-coded those, but that might break in future versions of iOS. They may change the curve for the dismiss to be a little bit faster than the show or vice versa. So it's a good idea to just always read those properties. But I like this approach for kind of translating something that is not so fun to work with, which is the notification user info dictionaries that come out of these, and translating them into something that is actually a lot easier to work with, and be able to map those and merge those values and treat our animation in a single way. And this will always keep our UI in sync with the state of the keyboard. Okay, now I want to talk to you about a really interesting publisher, and that is called Record Publisher. Now, this one is really different than what we've seen before, but it is really useful, as you'll see. So we can create one of these. I'm just going to call this RecPub, and that'll be a record publisher, and we have some values here that we can use, and the one I'm going to pick is output. So you can kind of think of this as like a sequence publisher, like it will emit all of these items in sequence. But unlike a sequence publisher, we can pass in our own completion, and I can just say, okay, you finished. Now, it's not going to understand what the failure type is unless I tell it in this particular example. So let's just say that this is an int and never. And now I have a publisher that if I subscribe to it, I will get those values. So for the completion, we'll get this. And then for the value, we'll also print that out. So we'll be able to see exactly what we specified in there. And if I run this, and it's kind of unsurprising, we get 1, 2, 3, and then finished. So it's very similar to what we've seen before, but if I have some custom error, let's call this custom error, which is a Swift error, and maybe we have an error type of, out of gas or something. Now I can specify that I have a custom error here, and instead of finishing, maybe this time I want to fail with that particular error out of gas. So now if I run this, we get the example 1, 2, 3, and then out of gas. So why would you want this? What is this useful for? Well, if you can think of like a specific scenario that you want to simulate, maybe in a test, then you can create a record publisher to essentially do that thing. So in this case, I have like the array of values specified up front and a completion, but we could also specify this in a different way. In this case, I can get my example in, and then what we can say is example.receive input. And then I can say, okay, you received 1, and then you received 2, and then maybe in this point, you completed with a failure. So we'll say receive completion, failure, and out of gas. So we can kind of build up our example exactly how we want to play out. And then here we can subscribe to it and see how that played out. So I get 1 and 2, and then the failure. So this would be great in a unit test, for instance. Now, another thing we could do is we could take the output of an existing publisher. So let's say I have a publisher that I call pub. And in this case, instead of doing recpub like this, we're going to say that I've got an example pub that is just 1, 2, and 3. And in this case, it's just not going to fail. So if I take this publisher and I take the completion and the value out of this, so we'll get the completion in, and then this one will give us the value in. If I create a publisher, let's call this a record publisher. So that's going to be a record publisher, and the types have to match up with the type of publisher that I want to receive events from. So in this case, I can grab the recording out of that. So we're going to call this recording. So this recording is a nested type. So we can take that type and I can use it inside of the sync for this publisher and say, okay, for this one, I'm going to say recording.receive completion and pass in the completion. And this one will say recording receive input and pass in the value that we just got. So at this point, now I've got a recording that I can use, and I can create another record publisher. So we'll call this recpub again. And this time I'll say record, and I can pass in a recording that I already have. So in this case, I'll pass in recording. Now at this point, it's just going to play back that recording that we made. So we get 1, 2, 3 and finished. So it's kind of neat how you can you set up a recording that matches your publisher's types, and then use that to record the events and the completion from that publisher. And then sometime later, you can instantiate a new publisher that will play out the events in the exact same way. So I hope your mind is kind of spinning with the different kind of possibilities that this would open up for you. And while you're thinking about that, let's point out one more really interesting thing. We saw how we can give it some output and a completion, and how we can instantiate a new record publisher with a recording that we already have. We can also instantiate a record publisher from another record publisher, But then there's this last one, and you can see that it's initializing from a decoder. And that brings up a really interesting point that, say I have a publisher and I want to save the recording results of that publisher to disk. I can do that by creating an encoder. We'll use JSON encoder here. And here I can say encoder.encode. We'll use a try there with a bang. And then here I can pass in my recording publisher like this. So rather than syncing to this recording publisher, I can just instantiate this from a recording and encode it. Now, this does have some requirements in that both of these types have to be codable, and never is not codable. So in order for us to get this to work, we can change this to maybe our custom error, and then give this an int backing type and also say that it is codable. So at this point, our failure type doesn't match up for this example, so I'm just going to set the failure type to custom error.self just to get this example compiling again. But then we go back down here, and now this has encoded this to some data. And if we want to look at that, we can print out that data converted to a string using the UTF-8 string encoding. And let's take a look and see what it looks like. You can see that we get this JSON structure that says recording, completion is success and true, and the output is 1, 2, 3. So as long as your types are codable, it works just fine. Now let's show an example of maybe one that fails. So instead of passing this recording like we had earlier, let's use this one that is going to output, say, 5, 6, 7, and then fail. So here we're going to have to tell it what this type is because it's not going to know unless I tell it. So here, if I say that we have a completion, now I can say failure out of gas. And now if we run this, we can see that it says success is false in our completion, and then the error is the raw value from our error enum. So what's cool about that is now I can take the output of some recording publisher and save it to disk and hydrate it later when I want to use it. So I can record some events and save it into a file, and then I can bring that back up and replay it back. So how would we do that? Well, we can create a JSON decoder, and we can say decoder.decode, and we have to give it the type that we're going to be decoding. So we'll say int and custom error.self, pass in that data, and that's going to give us our recording publisher that was saved from disk. And now at this point, I can take that recpub2 and I could subscribe to it and print out these events like this. And print $0. And now when we run it, you see we took this JSON from disk, turned it into a publisher, and then replayed all those events.